I'm Craig Mathias with the wireless and mobile advisory firm Farpoint Group, and welcome to another edition of Farpoint Focus. Today we're exploring the vital but complex world of testing wireless products and systems. While test engineering is of course the province of specialized solutions and expertise, we all benefit from wireless systems verified and optimized via the sophisticated testing tools, techniques, and strategies available today. A major challenge in deploying optimized wireless solutions is dealing with the fundamental variability inherent in radio transmissions through the air, including interference. For that reason, a key wireless testing strategy is the isolation of components from the local radio environment, eliminating these variables and assuring repeatable results. Fanny Mlynarski, the founder of wireless test equipment leader octoScope, has spent years dealing with this difficult engineering challenge. octoScope has pioneered a new solution, the octoBox, and Fanny helped us understand how an isolated, repeatable environment is of such great value.
In the octoBox, you will get the same identical results every time you measure. You will get the same identical results in multiple octoBox test beds because we tune each one precisely to match the other. You will be able to introduce realistic multipath and realistic path loss and realistic interference. You can do capture and replay of interference. So if you have a particularly bad site with a lot of neighboring traffic, interfering traffic, radar and so forth, we can replicate all that. And we can replicate it inside an anechoic, small anechoic chamber. Anechoic means non-echoing. That means that we don't have stray reflections. Everything's absorbed, but we can emulate reflections with a device we call multipath emulator. We can emulate traffic, or we can replay captured traffic and interference of other interference like radar, Bluetooth, microwave ovens, you name it. We can have broadband interference sources. The real solution is that we can replicate that for tens of thousands of engineers in thousands of labs around the world.
octoScope software engineer Ben Lampert gave us a demonstration of the octoBox and explained the function of the turntable.
So right now we have the octoScope testbed with a AP rotating on our turntable. We have that going coupled over the air, going through our MPE, which is our multi-path emulator. Then we have that cabled down to a PC client, and we're running a X-Chariot throughput test through that system. So we have a wireless access point on the octoScope turntable, and what this allows us to do is rotate the access point during a test. So there's two different modes. We could set a position and run a throughput test, or we can rotate during the test, and in doing so we can get throughput measurements independent of orientation.
In our next visit to octoScope, we decided to put the system through its paces, examining the throughput of a new 802.11 AC router. Fanny Mlynarski set up a simple but effective testbed configuration for us.
This happens to be our throughput testbed, and currently we are using it to test throughput of the latest and greatest 802.11 AC devices, and they are MIMO, as you can see. Some of them are reaching 4x4 configurations, and so getting top throughput and representative throughput is tough to do, both in the real world and in the box. So what are we doing in the box to emulate real-world environment? We have an anechoic chamber here, thick foam covering all the metal surfaces of the box, plastic rails, plastic turntable with a plastic shaft through the foam, minimal reflections in the box, and we have our MIMO test antennas here. These test antennas are connected to a partner device or a master. So for example, when we're testing an access point, our master or partner will be a client. And these pretend these are antennas of the client, of our partner device. And we are connected to the partner device in the bottom chamber, but we are emulating a real-life environment, and for that we need two things. We need multipath reflections, which we're emulating with our multipath emulator module we call MPE. And we need flat path loss, which we're emulating with the programmable attenuators mounted on the side.
Test scripts are easy to put together via tickle code, and the output of the test is tabular data that is simple to incorporate into, for example, Excel for subsequent analysis and rendering. It's also possible to use LabVIEW if a graphical user interface is preferred. As someone who spent countless hours dealing with the realities of testing wireless products in free space, I'm deeply impressed with the power and potential of the octoBox in improving engineering productivity and lowering costs. But perhaps now even more important is the octoBox's value in realizing the dramatic improvements in reliability, availability, and performance that end users demand. For Farpoint Group, I'm Craig Mathias. Thanks for joining us today.